Hello everyone. This video is about explaining how to use Excel to conduct your calculation in the investigation of the following card. So some of you must be at the point where you have recorded all your data, all the times, following times, through the photo gate for the different lengths. So you might all have different lengths, but that's not an issue for this tutorial. So to calculate the uncertainty on time, we know that the uncertainty is the maximum value minus the minimum value divided by 2. So we're going to use a function on Google Sheet. So you're going to type the equal sign, open parenthesis, and type max, open parenthesis, and select the data for which you want the maximum value, close parenthesis, minus, minimum, open parenthesis, again, select the data for which you want the minimum value, close parenthesis twice, and divide by 2. And that's going to be your uncertainty on time for 12 centimeters. Now you want to repeat the process, but instead of retyping the equation, you can just go to the bottom right corner and then until you get a small cross, and then you click twice and it will actually process the calculation or copy the equation all the way down. Now the problem is delta t is an uncertainty, so it has to have only one sig fig. So you're going to select the data and then go over the decimal, decrease decimal button until you have only one sig fig in each case. Now we need to calculate the average time. So the average time is obviously the sum of the times divided by 4. But it's also a function on Google Sheet where you just have to type the equal sign and average, open parentheses, and then you select the time that you want to average, so time 1, 2, 3, and 4, close parentheses, and press enter. Again, it's pretty straightforward. And again, if you want to copy the equation down, you're going to go to the bottom right corner and click twice to copy the equation all the way down. You can see that the number of decimals is the same as for the average time, so there's no adjustment to be made. So now how do we find the uncertainty? We know delta t, we know t. So by definition, uncertainty is delta t over t as a percentage. So again, we're going to just, since it's an equation, we're just going to type the equal sign, delta t, we click on delta on the first number, and divided by t for 12 centimeter lengths, and press enter. So now it's giving me the uncertainty, but as you can tell, there's way too many decimals, and we want it as a percentage. So we need to select the cell again, and you're going to go to the percentage button and click on it. And again, it's too many sig fig, so we need to reduce until you only have one sig fig because it's an uncertainty. And then again, to pull the equation, to copy the equation, we click on the bottom right corner and click twice, and it's going to repeat the same equation 4 times. Okay. Time squared is basically just the time, the average time we calculated times itself. So again, we type an equal sign under that cell, so equal average time multiply by the average time, and we get t squared. And again, we repeat the process. We click on the cell, go to the bottom right corner, click twice, and it's going to repeat the calculation that many times. Obviously, we have way too many decimals here, and we need to keep the decimals similar to the average value of time. So we can go back again to decrease decimal places all the way to 4 decimal places. Okay. As you watched in the previous video, you note that the percentage uncertainty on time squared is twice the percentage uncertainty on time. So all we need to do is again equal sign 2 times the percentage uncertainty on time and press enter. Again, we want this as a percentage, so we're going to type on format as a percent, and we only want one sig fig, so we're going to decrease the decimal places twice. And as we do this, our equation is ready to be copied. So we go to the bottom right corner and click twice to copy it. So the last step is to find the uncertainty on time squared. So since we know the percentage uncertainty and we know time squared, all we need to do is multiply them. So percentage uncertainty times the number itself times squared will give you delta t squared. So now delta t squared again at too many decimal places because it's supposed to be an uncertainty, should only have one sig fig. So we can reduce the number of decimal all the way to one sig fig. And now the equation is ready to be copied all the way down. Now we see that there is an issue with the last one. We only see zeros, so maybe we need to add just for that one specific, we add one decimal value. The goal of the experiment was to actually graph t squared on the x-axis and length on the y-axis. So we need to create a new data table with these values. So what we did is we copied the heading here, we copied the heading here, we pasted here, and then for the card length, since we recorded the card in centimeters, but for our graph we want it to be in meters, so we don't have to do any conversion to find the gravity. So card length is going to be in meters, since the uncertainty is plus minus 0.1. If we divide by 100, it's going to be 0.001 meters. Now we're ready to get the data. So the data for this column is equal to the data from here. And then we can repeat the process 5 times to get all the data points. For the card length, we need to work a little bit on the equation. Since the length here is in centimeters, we need to divide the length by 100. So it's going to be the equal sign 12 divided by 100. And again, go to the bottom right corner, copy the equation all the way down, and make sure that they all have the same number of decimal. Okay, our data is ready to be graphed, and this is going to be explained in another video. Thank you for your attention.